Can you imagine a world where robots not only work alongside humans, but also think, adapt, and make decisions just like us? Welcome to the remarkable world of AI-powered mechatronics. It's a fascinating field that blends mechanical engineering, electronics, computer science, and artificial intelligence. Picture a world where robots, powered by advanced AI, don't just perform tasks. They learn, they adapt, they make decisions based on the data they gather from their environment. These aren't your average assembly line machines, they're intelligent collaborators. Imagine a factory where robots and humans work together seamlessly. The robots don't just follow preset instructions, they learn from the humans around them, adapt to changes in real time, and make complex decisions autonomously. This is the potential of AI-powered mechatronics. It's not just about making our lives easier, it's about creating a future where humans and robots can collaborate, innovate, and drive progress together. Sounds like science fiction, right? But it's closer to reality than you might think. Take, for instance, the case of an AI-powered robotic arm developed by Google's robotics department. This isn't your everyday robotic arm. It's a marvel of mechatronics, an embodiment of artificial intelligence and mechanical engineering. But what sets it apart? The robotic arm wasn't programmed with step-by-step instructions on how to sort objects. Instead, it learned to do so through trial and error, a method known as deep reinforcement learning. Picture a toddler learning to stack blocks, making mistakes, and then adjusting its approach. Now imagine a robot doing the same. So, how does it work? Deep reinforcement learning utilizes a system of rewards and penalties to teach the robot. When the robot achieves its task, it receives a digital pat on the back, reinforcing the successful action. However, when it fails, it gets a digital nudge, prompting it to try a different approach. This method allows the robot